Well, good morning, everyone. Thanks for joining us at this workshop, and thanks to Swiss Re for hosting the event again this year. I think we've got another good turnout and a good mixture of people. It's always great at these events because we get people from the market, people from the model developing community, academics, users. There's always a sort of interesting mix of backgrounds. Unfortunately, this year, because of the circumstances, because we're not all in the same room, this is a bit less interactive than other years. So, previously we've tried to make this very hands-on, and we could be in the room and actually help with, some live coding and really getting hands-on to the software tools. We thought that would be sort of too difficult remote, so we are going to do quite a few demos in this morning's session. But it's sort of going to be a little bit more presentation based this year. Having said that, all of the code, all of the examples are in GitHub, so you can go away and try those after the session, and sort of give us feedback, shoot any questions that come up through that. One note on just generally running. I think everyone's muted apart from the presenters. But we do want to make this as interactive as possible. So if you can stick any questions in the chat as we go along, we'll be sort of stopping at regular points to sort of address any questions that come up, and hopefully have a little bit of a discussion around some of the topics that are raised. Great. So without further ado, let's get cracking. So the topics we wanted to cover this morning were talk a little bit about the platform and the software and how it fits together, and some of the things we're working on at the minute. We're going to take a look at some of the open data standards, so the exposure data, what's coming in terms of the results data, and what they look like. We're then going to look at how you go about constructing a model, what some of the data formats look like, and how you can utilize the model development kit to kind of run and test the model prior to deployment. And then we're going to look at some tools we've got for actually trying out the platform and getting a sort of quick test version of the whole deployed platform, so you can see it running end to end by the APIs, by the user interface. And then finally, we'll have a look at the user interface and how you can run an analysis via that. And I suppose through through this series of topics, we're very much taking it end to end. So the sort of foundational pieces around the software and the data standards, and then I suppose the life cycle of how you would go about building a model, taking it through onto the platform, and then ultimately running it via the user interface. So that was kind of the thinking around the flow of the sessions. Okay, so in terms of who you'll be hearing from this morning, you'll have Ben Hayes, who actually runs our sister consulting organization, but is also very involved in a lot of the model development projects and supporting the production Oasis systems. There's myself, Mark Pinkerton. I run the sort of technology side of Oasis LMF, and I'll be talking a bit about the architecture. Matt Donovan, who's our Oasis program manager, so he leads a lot of the community-facing initiatives and is very involved in the development of the data standards and the further refinement and design of the user interface. And then we'll hear from Sam as well, who's one of our developers and leads a lot of the systems architecture and the release processes and the automation that we've put in around that. Okay, so I'm going to kick off with 10 minutes or so just on the Oasis platform and some of the sort of foundational aspects to the system and design considerations. Just starting off with this slide, which I think Dickie showed in his conference presentation yesterday. And really, this is the sort of 10,000 feet view of all of the activities that Oasis as a sort of organization looks at. So I suppose on the right-hand side, the big red planet is I suppose what we're mainly looking at today. This is the actual software components, the platform itself, which is a very componentized architecture, and has all of the different bits for running and operating catastrophe models. In the center, the sort of blue planet at the top, we're trying to foster the development and adoption of a range of standards, both in terms of the data that you need to operate catastrophe models, and then interoperability standards, things like APIs, for running the platform within different systems. At the bottom, the sort of purple planet are the various deployment modes. So whether that's on the cloud, a hosted SaaS service, on-premise on a single server, there's lots of different flavors of this, and we need to have a flexible architecture that can support these. And then last but by no means least, on the left-hand side of the green planet are all of the model development companies that we work with. And there's a sort of subset that's actually not all of them, but we work with quite a large group of people building and deploying models into the system. Okay, so what are the it's always useful to sort of on the software side to really sort of distill out what are the sort of key use cases that we're trying to address. So the first one is really the sort of traditional CAT analyst use case. So as a risk analyst, we want to use the user interface to configure and execute models deployed in the platform. Then the second one, as a model developer, you want to use the MDK, the model development kit, to build and test models that you can then deploy into the platform. And I think a key idea of the design of the software is we treat those two use cases very much on equal footing. We're not just catering to the model execution. We view the model development process and creating tools to support that and ensure the consistency of the assets that are developed with the assets that are actually deployed into the platform. We put a lot of effort into sort of thinking about that and making it as kind of seamless as possible. Thirdly, then, as a software engineer, we want to use the API to integrate it into other systems. These sort of interoperability use cases are becoming ever more kind of important. And then finally, it's as a systems engineer, you want to actually operate the platform. And again, these use cases are becoming more and more important, as the platform is being run at scale. So if you've got lots of different models, lots of different versions, lots of jobs potentially, running concurrently, having the tools and processes to monitor and manage that efficiently becomes kind of ever more important. So drilling down into the sort of software itself, again, there are four main components that we think about here. The first is the actual platform. So that's the code components, the APIs, data standards, all of the tools that you need to actually run the models at scale. So that's really the sort of key heart of the system. Then we do have a user interface. I think Oasis is prime goal is to be an API-driven model execution platform, that can be run through a variety of tools or plugged into existing reporting or risk management systems. But we do have a user interface that I think is great either as a sort of evaluation, getting going with the system. It's very useful to be able to have that simple way of getting up and running with the platform, or, and this is where a lot of the development work has come from, outside of the core insurance, reinsurance use cases, looking towards, say, use in the developing world, like governments or other organizations, having a simple web-based front end that allows you to operate the platform, makes it much easier for those sorts of organizations to get going with catastrophe modeling. Third, the Oasis Model Development Kit. So again, I've touched on the fact that we view this as a really kind of key use case. We put a lot of effort into the consistency between the model development process and the deployed models. And we'll be having a look at that in a lot more detail later on in the talk, exactly what that means. And then fourth, the Oasis Model Library. So as well as providing a system for operating the models, we need to provide some way of actually managing the models that are available in Oasis. And what this means is we've got a library hosted in the cloud where we can collect all of the data assets. That provides a central repository from which the models can be deployed onto different production systems. And the other important aspect of that is it's integrated into our build system. So every time we publish a new release of the software, we actually regression test all of the models that are in the library to make sure that the numbers aren't changing, with the stability in the results that are coming out of the model. So that's a really important part of the platform, especially when we work with so many different vendors, and we've invested quite a lot of time in really getting that as kind of automated and robust as possible. Okay, and then in this diagram, it really just illustrates how these different components fit together as a kind of ecosystem. So at the top, you have a model developer working directly with the model development kit to build and calibrate the model. Once that's done, they then publish the model assets into the cloud-hosted model library to make them available to users. And then at the bottom, we have different systems with the fully deployed Oasis platform that kind of models published into them for use. And then the two main ways of actually using the system, that either you've got a risk analyst directly using the web-based user interface to operate the models, or it can be just plugged in via the API and integrated into the other systems. So that's what the kind of end-to-end ecosystem looks like. Drilling in then a little bit more, just to give you a flavor of some of the technologies we use. So, as an open source development firm, I think we firmly believe in the sort of benefits and utilities that open source products give you. So, from the technologies that we use, we very much use standard open source approaches. So at the core, we've essentially got a Python package that we write ourselves that encapsulates all of the, I suppose, the sort of domain-specific catastrophe modeling analytics. So doing simulations, the financial modules, the loss curve calculations, etc. We do have some C++ components for the more performance-critical aspects, but we're increasingly consolidating on the kind of Python side. Below that, on user reporting, our user interface is built using the R statistical language. So there's a lot of powerful data visualization tools that come through that. We do use Jupyter notebooks. I think we'll be seeing some of those later in the this morning's sessions, and they're a great way of sort of interacting with code. And getting visualizations and having easy reusable best practices, and then thinking out the deployment side. So again, pretty standard ideas and frameworks that are very widely used in the broader data engineering world, and kind of very applicable to CAT modeling. So containerization, Docker, this is a way of this is increasingly the industry standard way of deploying systems into production. They're like very lightweight virtual machines. And the thing that's particularly powerful from our perspective is that that allows us to, so some of the models we work with have their own set of custom software components. If there's very, specific methodologies that the modelers have their own code available for. The use of Docker containers means that we can package pretty much any software assets and deploy them into the Oasis system. So that's been a very powerful aspect. We then use other tools like Celery, which is a Python job management framework, or Django, which is a web server API framework, to provide the sort of enterprise deployment at scale. And then on the right, one of the things we're working on at the minute, this slightly old slide, we're actually in test. We've done a lot of this work in 2020 and are sort of testing it at the minute. This is really looking at much bigger cloud level deployments of the platform, using systems like Kubernetes, Azure, AWS, etc. Okay, so drilling down a little bit, I think it's useful to understand the sort of end-to-end model execution, what actually happens from a data perspective when you run an analysis in Oasis. So starting at the top left, the typical use case is that an insurer or reinsurer will already have an exposure and results management system. Oasis is not intended to be a full end-to-end data platform, but it's very much designed to interoperate with the existing systems. So the first step is to extract exposure data and transform it into the OED format, the open exposure data format. And once you've done that extraction, you then upload it via the Oasis API into the platform ready for analysis. The third step then is to actually run the analysis. So you configure that, you choose the model, you configure the various parameters that are available, and then you kick off the analysis and monitor the status. This is obviously an asynchronous job because large models, very big portfolios, you can certainly be looking at runtimes of up to an hour plus in some cases. So we have a series of API calls that allow you to sort of check the the status of all of the running jobs at any given time. Once they're complete, you then are able to extract the results out, where in the process of adopting the analog to the OED, the ORD, the open results data format. And once the results have been published, then they're available for further processing or publishing back into a results management system, etc. So that's the kind of end-to-end flow of data when using the platform. This is sort of what it looks like at a slightly lower level. Then I'm not going to go into this in a huge amount of detail. I think the important points to note are, so each of these little boxes with the blue wheels, they're all these Docker containers that I mentioned briefly. I think the key ones are we've got API, we've got a series of message queues, and then on the right-hand side, we've got a series of these model worker containers. So these are essentially little virtual machines that know how to execute and the particular logic for a particular model instance. And the key idea is really, those set of three workers are for three distinct models, but you can sort of scale that up and down as much as you want for deploying lots of different models and versions into the platform. The other neat thing about the use of Docker containers is either, and Sam will show you this later on, you can install the whole platform onto a single machine and have a nice sort of evaluation environment, or there's a lot of very robust frameworks for deploying this across a whole cluster of machines, but you're using exactly the same components with just the sort of underlying physical network setup being different. So this just talks about the specifics of the components of it. I'm not going to go into that. So yeah, so I think finally I just want to briefly mention one of the things we're working on at the minute, which is the cloud native model execution. So at the minute we can scale out the system, but our sort of unit of execution is a portfolio model. So for large models or large portfolios, you still need to scale up, you still need a big server to make that run efficiently. So the work we've been doing in sort of the first half of 2020 is to really split that up so that the unit of work is a handful of events from the stochastic catalog, which means that for a single analysis, you can run that in a much more distributed manner. Essentially, throw as many machines as you want at it in order to get it to run in whatever time you want. We're using very standard Python libraries and these Docker container approaches to do this. And what this means is that we can actually interoperate with really any of the approaches that different organizations are taking, to manage their compute at scale, because we certainly see similar patterns in how the different companies we work with are doing this, but there's no one technology that everyone's using. People are going with different cloud providers, people are going with different container orchestrators, so the Oasis software has to sort of play nicely with any of those. Having said that, it is important that we at least have one reference system that we can test against and start getting some benchmarks for this work. We're working quite closely with NASDAQ, who have a SaaS offering around Oasis, and they're spinning up a system using AWS and Kubernetes to run this massively at scale. And we don't quite have the numbers yet, but I think in the next sort of month or so, we'll start being able to sort of plot, run times against cost of analysis, because it's actually the economics that are quite interesting when you move into the cloud scale stuff, for running big catastrophe models, which I think will be pretty exciting and kind of really interesting to see how that stacks up. And in particular, what sort of new analytics will that enable if it's possible to run analyses very quickly and in a very economic way, things like starting to run ensembles of models and understanding some of the uncertainties and dependencies on the parameterization of the models and actually getting that reflected in the loss curves. I think it's something that we're starting to talk about with the vendors, that this sort of design will really enable. And finally, I just wanted to talk a little bit about some of our sort of code housekeeping. Sam is actually going to sort of give you a little guided tour of our GitHub repositories later on. So GitHub, all of our code and documentation is available on our GitHub site. We have pretty much a monthly release cycle. Like I said, we've invested quite a lot in a full CI, a full continuous integration system. And what that means is that as we develop, we're constantly running a battery of tests against the code. And then at release time, we run a very complete set of tests and also regression test all of the models that are deployed into our CI system. I think we've got about 23 full production models now. And then we've got a very automated process now of actually publishing that software, publishing change notes, etc., out to the user community. In terms of communicating with the team, raising issues on GitHub is absolutely the best way to do it. I think we want as much interaction with the community and users through GitHub as possible. And I think we're starting to see commits from other organizations as well, which is very much the vision of where we want to get to with the open source initiative. We do have a support email, and finally Slack for joint projects. One of the things that we find very beneficial if we're collaborating on a particular deployment or a particular model development project is to open up a Slack, a sort of messaging channel, and have a much more detailed discussion around that. That's actually something we're thinking about doing for the community more broadly as well. which is used quite effectively in other open source projects. You essentially just have a chat channel that discusses issues, discusses methodologies, etc., that's open to the whole community. So that might be something that we put in place this year. So I think that's all from me as an introduction. I'm just going to have a look and see if we've got any questions before handing over to Matt. Okay, so if anyone's got any questions on the architecture, don't see any questions, in which case I shall hand over to Matt to talk about data standards.
Okay, thanks, Mark. So I'm Matt Donovan. I'm going to spend just the next 10 minutes or so talking about ODS, the Open Data Standards. And so ODS essentially is now created by Oasis LMF, and we're governed now by a steering committee. It's made up of attendees from reinsurers, brokers, insurers, and cat vendors. And the aim generally is to provide the industry with a robust, open and transparent data format. I'm assuming some of you might know more about this than others, but I think it's important to talk about OED and ORD. So the ODS is comprised of both OED and ORD for exposure and results. Mark did briefly mention results earlier. Today I'm just going to focus on OED. ORD, just briefly, it was the product of the Lloyd's Lab project that we participated in at the latter part of last year, and it's looking to be implemented into Oasis over the next 6 months, or hopefully before the end of 2020. And the idea is that all model output formats will be consistent across models and vendor, and the idea is to support transparency, efficiency, certainly with data transfer and model comparisons and validation and things like that. So there is more on our GitHub, but like I said, today I'm just going to focus more on the OED. And all of the information on governments and processes and releases and tracking are all available openly on our GitHub repository, which is the link there. And we will use GitHub a lot to monitor and to manage and communicate all of the information around releases and tracking and different versions and so forth. So OED, like I said, is the open exposure data. And this was, the development of this was led by NASDAQ, which was formerly Simplitium, and Oasis took charge of it, or took over the repo on the 1st of May this year. It was developed in close collaboration with AIR, and so we used their seed database as the basis for OED. So I suppose the advantages of OED is that it is quite flexible, and the idea is that it can accommodate a lot of multiple different vendors and developers, and there's a lot of different requirements from those different developers, and so we do have some flexibility in back tables and in the databases, certainly around geography and other data. So during the development there was a lot of market input, and so the idea is that OED does support quite an extensive scope of combinations of limits, deductibles, special conditions from the coverage level upwards. So the idea is that we can accommodate pretty much, I don't want to say 100%, but near enough all of the possible combinations you can see in financial terms. And we support comprehensive step policy function as well. So I think it's important to note that OED at the moment can actually support a larger scope of the data that is actually being used at the moment in Oasis. So this obviously is to accommodate any further requirements. So the models available in Oasis, they're not using the whole scope of fields and the capability of OED. And just a bit about the structure. So I'm sure a lot of you are familiar with the current proprietary data formats out there, namely SEED and EDM. And so there are 4 input files of OED. You've got your location, account, and your 2 reinsurance files, and I'll go into details about those shortly. They're all CSV, and there is around 29 relational SQL tables in the back end. Just something to note that all reinsurance in OED is captured in the input files, so there's nothing to apply in the user interface post import. So just a bit about location. Again, as I'm sure a lot of you are aware, it is contains all of your address information, your primary and secondary modifiers, your coverage TIVs, and your location level limits and deductibles. And for OED, it's the only compulsory file needed to model any ground up or economic loss. So if you weren't interested in applying financial terms, you wouldn't need an accompanying account file. You can just run the location file, which will only model your ground up. And so there's, like I said, there's a large number of fields to cover an extensive scope of these deductibles, and I've listed the different limits and deductibles here. You go from your regular to max min, and then there's some more niche ones, or homeowners and things like that, and then some of your standard limits. So we do actually account for annual aggregate limits, percentage of loss, percentage of TIV. And also in the location field, there is a lot group field, which is quite good to use for reporting purposes. So you can group or link a number of locations together if you need to. So account file, again, it has a lot of fields. I think there's over 200 fields that account for a very extensive and detailed scope of your combinations of limit deductibles and your special conditions. And you can also isolate locations within those policies and accounts if you need to apply financial terms to specific locations or perils, or if you want to exclude some perils. And like I said, there's a lot of function for step policies, a lot of triggers and payouts. And similarly to location, the AC file also has an AC group field. Again, if you want to link a group, some accounts for reporting purposes or binders, you can do. And then just onto the reinsurance files. So we have two reinsurance files in OED, your info, reinsurance info, and reinsurance scope. So your info file will contain all of your reinsurance contract details and your type of reinsurance, from excess of loss to your per risk and your quota share and your surplus share. And it contains all of the layer information, your attachment points, your limits, your deductibles, in your priorities and your reinstatements. And then the scope file contains the details that are related to that info file. So it will be the exposure that the reinsurance should apply to, which is set out in your portfolio numbers and your account and policy number fields. We also have your risk level, definitions of risk, and then also your ceded percentage when you're looking at surplus shares. Okay, just touch a bit more about flexibility. So the format in OED is to use multiple rows, duplicated rows for the same policy and account. And this way, it's quite easy to see and lay out and code your financial terms. So it's a good way of seeing where your special conditions are applying and things like that. And we use a 3-digit peril code, again, to allow flexibility when modeling your complex financial terms. So just an example here, you can from a semicolon, you can put what perils are included in that or excluded. And we also have things flexi tables, so you can actually enter some additional fields and values to store where there's actually not an OED field available for that. And just an example here, we have the flexi lock ZZZ, and you just remove the 3 Zs and replace it with your new field. So it's just a good way of storing information. And geographical fields. So like I said before, OED has to accommodate multiple developers, and those developers might have different requirements, certainly around geographical fields. So we have 5 pairs of fields, which are called geog scheme and geog name, so 1 to 5 for both. And it just allows a developer to define their own geographical scheme using a code. So the example we've used here, which is the one we use in the documentation, is that a developer might want to split a country up into 4 regions, A, B, C, D, and your scheme could be called quad, for example. So you would just essentially put quad and then use A, B, C, and D for the name. And this is just a way to include your specific or unique, if you have one, geography schemes. And for reporting purposes, you can also, a user rather than a developer can just stick an X in front of it to avoid any clash. And there's a lot of codes that are included that are currently used on our on our GitHub repo. And I'll just go through a few of those now, actually. So these are the ones that are currently supported. So we have County, and then we have different resolution levels of Cresta. We have the CRSL, which is your specific for cat risk solution models. And then we have things specific for Australia, for the GNAF, G+, which is a Google version, ICA, again, specific to Australia. And then we have a lot of the UK different postcode, sector and units and resolutions. And obviously, you know, you would add these or would implement these if you needed your own specific one. So I just want to talk a bit about supporting documents. So we have the OED, or Open Exposure Data spec spreadsheet, and also a corresponding open exposure data PDF or Word document. This has a lot of information in it, actually, and it's worth going on the GitHub to have a look if you're not familiar with it. And I've got some information here, but I think it's probably better if I just show you. So hopefully you can see this, you know, Excel spreadsheet with multiple tabs. So if we go into the OED input fields tab, you know, simply you can just filter on whichever file you want. So let's look at the app file, for example. So this is all of the available fields in the app file. As you can see, there are quite a few of them, and it has the corresponding description and data type and all the information you might need. And if you click on one, it will then take you to another tab. If I just zoom in, and it'll give you all of the codes and types of what the deductibles and limits and types are, all there. So again, if I just filter on lock, you can see there's, you know, quite a substantial amount of fields there. So this will give you all of the fields for that input file. And then just moving a few more tabs, we have our 3-digit peril codes here. We have more financial information. And then maybe more importantly, it's worth looking at the occupancy and construction values. So as you're aware, you know, we use, like SEED and EDM, we use occupancy and construction codes. And again, we have what those codes are and a detailed description of what they are. So they're the codes you'd use. And again, so I'll just zoom in again, construction, the same as occupancy, you'd be using your codes, and you can work out which, using the description, which would best accommodate what you need to model. And then again, details on currency and country and all sorts of information. So this slide is just explaining that. I think it's probably better to show you. So it's worth going to the GitHub location and just having a look. And just finally, before I hand over to Ben to talk about model developer kit, just the structure of the field names used in OED. So we split it out here. So we have the hierarchy first, again, your location, policy, and count, the financial term for what it is, and then the code, which ties back into the spreadsheet I just showed, and what code it is to determine what kind of deductible limit you're applying, and then the coverage at the end here. So if you go to the GitHub repository, we can, there are some documents there, and the associated Word document or PDF document that has quite a lot of useful examples in there of how to code specific financial structures and financial terms, and which fields and information to include in those. So it's worth having a look at those. That's all I wanted to talk about for data standards. If I have a look to see if there are any questions. I'm not sure I can see any. If anyone has any other questions. If not, I'll hand over to Ben to talk about Developer Toolkit.
Thanks a lot, Matt. So I'm Ben Hayes, and I run a company called Oasis Palm Tree, which is a consultancy company. It sits alongside Oasis and helps people with kind of implementation or integration projects or support functionality ongoing if you want to run Oasis models. So we're available for that. It's not a compulsory service, it's completely optional, but we are available. So Mark asked me today just to talk through a little on the model development kit, which we'll go through. But just prior to that, I thought it was worth doing an introduction to Oasis files themselves. because I noticed there are a lot of fresh names on the attendee list that I hadn't recognised. So an Oasis model, just briefly, is made up of three parts. There's a hazard component, a vulnerability component, and an exposure component. And these are kind of strictly independent. The Oasis kernel brings them together in the middle. There are some kind of common references that are needed to make them interact properly together, but they are three distinct components strictly. So we'll go through them in order. We'll go through hazard, then vulnerability, then exposure. And I'll talk a little bit about what each of them are. Just to exemplify this a little bit, we'll use a model that we often show called PyWind. For those of you that haven't seen this before, it's a fictional model, and it's based on a town in the middle of England. It's actually the most kind of at-risk town in England, I think, because it sits in a floodplain and it's on a fault line. I'm not sure how many windstorms they get, but the first model we're going to go through here is a windstorm model. So we've made up this model just to show how things work in Oasis. So here we have a little map of Melton Mowbray, and the first thing we do is invent a synthetic event to hit this town. This is a windstorm, as I say, so we've got the wind passing from kind of west up. From east up towards the northwest up there. And I intentionally picked event 3. This will all tie together later on because I think Matt will come back in a little while and show us the UI, and this should all fit together with an example in there. So the first thing we do after deciding on our events is we break up the area we want to represent into what we call area perils. So in the case of PyWind, we have 100 area perils, which are just grid cells. They're all identically sized. They don't necessarily have to be. In Oasis terms, an area peril is just an integer representation of an area for a specific peril. So in this case, we're doing wind, so say. We've got equal size grids here. They could be variable resolution grids. They could be postcodes. They could be administrative districts, whatever is most appropriate for the model. But for simplicity in PyWind, we just have an equal grid like this. But in Oasis terms, it's important just to remember that they are just integer IDs representing some kind of area. And the way we build our concept of a hazard footprint is to interact the event with our area perils. So we have our event 3, which moves across the kind of top right corner of our map here, and it hits some of the area peril cells. Now, in Oasis, we represent the footprint as a table of integers, which represents that interaction of that event with those area perils. And the event in each area peril will have a different intensity, which is also abstracted out to an integer. And we support the concept of a probability distribution of intensities across that area for the event. Now, most of the models we deal with, and the example here, just have point values. So the probability is 100% of a particular intensity in a particular cell. But you can split that out to have some kind of secondary uncertainty inside of there. If, for example, you had quite a coarse cell, and you had the potential for lots of different variation of intensity within a cell, you could build a probability distribution for a particular event area intensity combination. In this case, we just keep it to a single probability. It's a little easier to show. So we pick out one of these cells. So the cell I picked out here is area peril cell 59. You can see it on the map there. In our footprint file, then you can see that for event 3, for area 59, I have 100% probability of intensity bin 29. And my intensity bin dictionary tells me that intensity bin 29 represents a wind speed of somewhere between 202.5 miles an hour and 202.5 miles an hour. So it's going to be 202.5 miles an hour. You can see some of the other bins there have broader spreads. The intensity bins don't have to be uniform. They can be variable again. and they can start at a particular, they don't have to start from zero, as you see that. So you pick some kind of sensible minimum intensity that is damage causing, and build your model around that. So the footprint is really just a representation, as I say, a probability distribution of intensities per area per event. And we can get lots and lots of events in here. I've only showed a subset of the data here for a single event, event 3. In the PyWin model, I think we have about 1,400 events. In real model, that can be much larger. We have 50,000, 100,000 events, sometimes into the millions for some certain types of perils. But it's all represented in the same file. So the footprint file holds the data for all of the events. And they can get quite large. We have some that, some of the production models are kind of tending towards a terabyte in size, even when stored as a binary format, which is quite efficient. So they can get quite big, but we have some, inside the Oasis calculation kernel, we have some quite clever ways of indexing that file and getting out the data that's required in an efficient manner. The only other file I haven't mentioned on here is what we call the area peril dictionary, which is a definition of these cells. So I have my 100 cells there. The kind of file at the top here shows what each of those cells, the kind of vertices of each of the cells. This is not an essential file for the running of an Oasis model. It's just a reference file. Similarly, for the intensity bin dictionary, we don't use this information inside the calculation. It's just a reference dictionary so that the data inside the footprint file means something if we want to interrogate it. So that's how we represent hazard inside an Oasis model. Going to the next stage, vulnerability. So again, we have probability distributions. Here we do tend to capture the, or model providers do tend to capture the secondary uncertainty. So the definition of a vulnerability function is a probability of damage for a given intensity. Importantly, we do have to have common intensity bins with the hazard. So if you remember my intensity bin dictionary here had 1 to 29 for my wind speeds, ranging from kind of 62 to 67.5 up to 202. My intensity bins for my vulnerability do have to be the same in order for those two bits of data to marry up. So intensity bin 1 is that 65 miles an hour range around there. Intensity bin 29 was my 202 mile per hour range that we saw in the example for the cell we looked at. And then we also have this concept of bin damage factors. So in my PyWin model, I've got 12 bins representing damage. 1 represents no damage at all, 12 represents complete damage, and 2 to 11 represents some ranges in between. So 0 to 10%, and then 10 to 20, 20 to 30. Again, in PyWin, these are uniform bins, but they don't necessarily have to be. Model providers can build this as is sensible. And our vulnerability functions then become probability distributions of, for a given intensity, which we see at the bottom here. So our intensity bin 1, which was the very low wind speed, we have a probability distribution of damage. So for 65 miles per hour, for this type of property, for this vulnerability function, I have a 65% chance of intensity bin, damage bin 1, which was, if you remember, 0 damage. So with 65 miles per hour, I have a 65% chance of no damage at all. And then a 14% chance of 0 to 10% damage, 6% chance of 10 to 20, and a 14% chance of 20 to 30. And importantly, these are kind of discretized closed form distributions. So this doesn't have to be approximated to some kind of assumption of a statistical distribution. These can be kind of lumpy distributions to represent more complex vulnerability functions of types of buildings. Just going over to the other side of the equation here. So for my intensity bin 29, which is my very high wind speed, 202 miles per hour, I obviously have much higher probabilities of higher damage. So I've got 66% chance of my complete damage in this case, and then a 14% chance of 90 to 100% damage, and so on through these scales. But with a very high wind speed, I'm going to get some damage. With a very low wind speed, I've got a 65% chance of no damage at all, and there'll be some range in between there. So I've just cut these off. But each of the intensities 1 to 29 will have some damage distribution inside it. And similarly to what we saw before, in Oasis terms, these distributions are stored as a table. So for a single vulnerability function here, vulnerability function 1, for intensity bin 1, which was my 65 miles per hour, roughly, I had my 65% chance of damage bin 1, which was 0 damage. So this 65% chance here is calling back to my big blue bar on this chart over here. And my 15% chance, 14.6% chance rounded up there, is my red bar here. So it's just a table representing what we've just described in vulnerability functions. I say very important to have a common intensity bin dictionary. So this is the same as what we saw on the hazard side. I can have as many vulnerability functions as I want, which map to some kind of property of exposure. So in this case, we've got occupancy codes. For my different types of occupancy mapped to different types of vulnerability functions. And then my damage bin dictionary is what we described about these different bars over here. So it's just giving meaning to these integer indexes that are represented in the vulnerability file. So that's how we represent vulnerability. And then I've got the example that we saw before. So from my intensity bin 29, as we saw that it had a high wind speed, and we saw that distribution in this chart here. And then it can all hang together, and just reiterating, this is why the intensity bin dictionary is important to be a common frame of reference across both sides of the equation, because it does hang these two files together. I think, as I mentioned earlier on, this is not actually used, this information is not used in the calculation kernel itself, but the important thing is that intensity bin 16 on this side means the same thing as intensity bin 16 on this side, because this table and this table come together in the calculation kernel to work out what the effective damageability distribution is for the combination of well, for a specific location. So that's what a complete model looks like in Oasis. It's a collection of these files, generally all integer IDs representing something that's meaningful to the model developer, but importantly, in Oasis terms, they're just integer IDs. And that's one of the reasons that's important, is because these can mean anything. So here we're looking at windstorm model, and these were wind speeds. If we were to do a flood model, these could be inundation depths. If they were, if it was an earthquake model, they could be peak ground accelerations. But in Oasis terms, they're just integer IDs which represent some kind of intensity. And we have events that have intensity, and we have vulnerabilities that have damage according to intensity. But the intensity can be anything from an Oasis perspective. Okay, jumping on to exposure data quickly and how that fits into the equation. Matt's already explained a little about what the OED is, the Open Exposure Data Standard. This is the standard that we support in Oasis. And when we're handling exposure in an Oasis model, we have what we call a keys service or a lookup service, which maps exposures to area peril and vulnerability IDs, which is how it plugs into that hazard and vulnerability concept. So an OED file for our Pi Wind example might look something like this, and we've got some kind of unique location number. We've got a latitude, longitude to tell us where it is, some kind of information about the address and postal codes, some kind of occupancy code to tell us what the property is. This is a residential property. Construction codes tell us about what it's made of. And then we've got TIV values and something about the perils that are covered, which Matt's already touched on. But importantly, our keys lookup service, which is our exposure element of the Oasis model, uses some of this information to map to an area peril ID. So it might take a latitude, longitude and map it into one of those cells. in our case, we had occupancy codes, which were our vulnerability drivers. So these occupancy codes would map to a vulnerability ID inside the model. So the keys lookup service gives us a model-specific version of the exposure data. So we have these keys which map it in, and we get some kind of TIV, so insured value, out from the exposure data as well. But we build quite abstract representations of the exposure data which just fit in with those integer IDs. The other part of the keys lookup service, which is quite important, which I'll just touch on very briefly, is it also validates the exposure data against the model. So what might happen is you enter, say, 1,000 locations, and actually 800 of them get IDs and 200 of them don't, because they're maybe outside of the geographical realm of the model, or they're vulnerability functions which aren't supported. The key service also returns that information to the user. So it will say, these 800 are mapped, these are the area peril IDs and vulnerability IDs, these 200 were not mapped for the following reasons. And that's quite important, particularly if you're running against multiple models. If you're running the same exposure against different models to get different views of risk, it might be that the different models represent different areas. So you need to understand you can't just compare the results one for one if you've got different models that represent different geographical areas. So the keys lookup service alerts you to how much of your exposure data will be modeled in that specific model. So getting on to the model development kit. So that was all the kind of preamble just on what an Oasis model is for those that are new to Oasis. The model development kit itself is a Python package and command line interface to run Oasis LMF models locally. It helps you to kind of build and test and run the models as they're being developed, or once they're developed, if you just want to run stuff and you've got all the stuff locally, you can do that. It's quite lightweight, very easy to install. It's just a pip install. For those that are familiar with pip, it's just the Python installation package. This is the command that you need to run, just pip install Oasis LMF, and it will pull all of the relevant components to run the framework effectively. We'll go through some examples of that in a second. The workflow that sits behind the MDK is really, I mean, there are three big blue boxes in the middle here that we'll look at, but it's really a two-stage process. There's a kind of an exposure validation step and preparation step at the beginning, and then there's the actual execution of the loss model itself. And just going through it, we at the bottom here, we've kind of got files. In the middle, we've got the processes that we're going to run, and at the top, we've got this concept of what we call model data. So these are static pieces of data that are associated with the model, and these are a variable piece of data that's entered by the user generally. So we start with an OED exposure set of files, and we pass that into the MDK, and we run a process called generate keys, which is that keys lookup service that we've just touched on. So this takes the exposure data, maps it against the specific keys data relative to the model, and says, look, here are the 800 locations of your 1,000 with their area peril IDs and vulnerability IDs, and the 200 that didn't map. So you get an idea at this point what you're going to actually model, and you also get some model-specific representation of the exposure that we've talked about. What we then do is we pass that into a second process called generate Oasis files, which takes our initial exposure data plus our generated keys data about how that exposure fits into the model itself. And this generates some input files to the Oasis kernel itself. And these are very abstract files at this point. These are similar to what we saw for the Oasis model representation files. These are just integer IDs effectively with some floats to represent insured values. But this combines the area peril ID, the vulnerability IDs, the TIVs. It's just the representation of the exposure data in Oasis terms, but there's no human readable part in here really. This is just very efficient computer readable binary files. And these are passed into the generate losses function, which is the execution itself. This is where the kind of core KTools calculation kernel goes on. This runs the whole Monte Carlo simulation to generate our simulated losses using the full model data, the hazard and vulnerability data that we've seen already, and then spits out the output files as we've requested. So there are really these are three separate MDK processes, which we can have a look at in a sec. There is a kind of overriding MDK process just called run, which will run all three. If you point it to, these are my exposure data, this is my keys data, this is the process that I want to run, then the run process just runs the whole thing end to end. And that simulates the losses. It runs exactly the same set of data, set of processes which would be run in a distributed deployed system. So importantly, all of these processes get inherited by the MDK, but also by the deployed system, which Mark's talked about already. Okay, so getting into the kind of the meat of it, generally MDK processes follow this kind of command structure. So we've got Oasis LMF, some kind of subcommand, and then a load of options. I just point out, if you are playing around with this, everything has a -h option. So if I run Oasis LMF -h, I get help about what's available underneath that. So I've got a number of subcommand options here, admin, test version, and you can't see this because it's a Johanna file, but they all have some kind of description about what they do. And similarly, if I go down to the next level, so Oasis LMF model -h, which is my options here, it gives me the options that I can run with Oasis LMF model subcommand. And you see some of the ones that we just saw on the workflow diagram here. So we've got generate keys, we've got generate Oasis files, and we've got generate losses, and we've got run. So these were the four that I went through in that workflow diagram. So then we can just run, so say, Oasis LMF model run -h, again gives me a load of options that I can run inside there. Couple of files that I should just mention. There is a config file that we can use just to make things a bit quicker to run. I think on our previous line, you see when we run Oasis LMF model H, we see there are lots of options that we can run after that, and we can list all of these out from the command line and run a kind of big, long, complex command line set of arguments, or we can refer to a config file inside there. And a config file just stores all of the options that we want. So we've got a location file that we want to run here. We've got where our model data is. We've got where our lookup data is, or our keys data. So we've got a number of things that we can just store. And then when we want to run it, we can just run Oasis model run with a -c for the config and refer to this Oasis LMF JSON file. So this just is a bit of a shortcut to reuse a lot of these things rather than typing all of the options out every time. The other file that's worth mentioning is what we call the analysis settings file, which should be referred to inside our config file. So you see there, I can tell it which analysis settings file I want to run. And the analysis settings file tells the execution itself what to do. So we say how many samples we want to run in the Monte Carlo simulation. We've got the different types of outputs we want to run in this particular example. So for ground up losses, we want average annual losses and event loss tables, loss exceedance curves, different types there. And this has to be put together for the MDK, so this can be written out, but we've got some templates. There are some schemas available to show you what can go in there. In the UI demo, which we'll see in a little while, this is all generated behind the scenes. So the UI kind of cuts out the need to do this, so you don't have to generate a file that says number of samples. The UI just has a control in the front end that says how many samples do you want. You say 10, it generates this file with all of your output options. Matt will come on to that in a moment, so we can refer back to that in a sec. Okay, so I can go now. If I cut out of this, hopefully you can still see my screen. Get the messages from Mark as we're going. So Mark's already referred to the GitHub repositories that we have. If you go to github.com/Oasis LMF, you see a load of these here. I'm going to be looking at the PyWind one, which is our toy model that we've been going through in the example. I've got that cloned into my repository here. Hopefully you can see this. And then I should just be able to run, have a look what's in there first of all. So we've got a load of stuff. We've got this Jupyter notebook, which Mark mentioned already, and there's it used to be called IPython notebook, now called Jupyter notebook example inside here. And I think we should just be able to run this. So if we type Jupyter notebook and then refer to the file, it should spit up a notebook. Some of you may have seen this before, so let's make that a bit bigger. So this notebook in PyWind takes us through some of the file structures that we've gone through in the presentation already. But you can see them in for real here. And then there's some MBK bits at the end, which we can go through. So Jupyter Notebook's quite a handy way just to kind of skip through a few of these. So we can store kind of some Python code which shows up things. So we'll go through some of the files first of all. The first one we're going to look at here is the area peril dictionary, which we saw already in the presentation. So this is our area peril dictionary here. We can see the vertices of the cells that we talked about. We've got some area peril IDs up here. Now I did in the demonstration, in the presentation, I only looked at the wind element. So the PyWind, the full PyWind model does have a storm surge element in it there as well. So we have different peril IDs. WTC in OED terms is tropical cyclone, and WSS is the wind storm surge. So I do have the ability here to have multiple sub-perils stacked on top of each other inside the same model. So the example we saw had 1 to 100 as area peril IDs. Here I've got 101 through to 200 as well to represent my storm surge. But we'll just focus on wind in this demonstration, just for simplicity. So we've already seen this in the presentation, but this is what it looks like for real. And you can clone this repository and run this yourself if you want to. So I think this just takes a second. Let's run that through. So this is just using a little Python library called Folium, which will map our area peril dictionary. It just takes a little while on my, this is all running locally on my laptop, so it'll just take a second or two. But we got some kind of mapping capability here, and just to show what Jupyter Notebooks is like. And these are the kind of 100 cells. It's not rendering magnificently. They should really touch up to each other. But you can see like the 100 cells around Melton Mowbray that we saw in the presentation. And then we can go and have a look at some of the other files that we've seen in the presentation. So our intensity bin dictionary, familiar with this, we've got bin indexes 1 through to 28. And we can see our windstorm bits there that we saw before. And that will go down. We've just returned the top 5 rows here, but we could show all of it. Let's try that. Brave to change things in real time, but we'll have a go. So that's what they look like. Okay, so I've got my 1 through to 29, which was my windstorm, and what I didn't mention before was we've got our inundation depths of flood here as well. So we've got additional intensities to represent the additional sub-peril in the model. In the presentation, again, we just looked at wind, but we do have additional intensities to represent flood damage here in the same model. Going on, let's have a look. So the footprint we saw already. So we had events, we looked at event 3. This is for event 1 in this example. We've got per area peril, per intensity, we've got probability distributions. So these were much lower intensities. The reason I picked event 3 was because they were kind of meatier, more interesting intensities. But you see event 1 has just got very low intensity bins, so it's got hardly any damage. So not quite as interesting to look at. And then we can visualize the first 5. So this is again just using some of the Python libraries to represent graphically this data. And this is very similar to what we saw before. So event 1, all white, which was what we saw just above there. Not much intensity at all. Event 3 was the more interesting one that we saw in the presentation. So I can see kind of very intense wind activity in this top right corner here. It's kind of northeast corner, which is what we saw in the presentation, and less so down here. So you remember the presentation, we had the big arrow going up across that northeast corner. Okay, so going on to the damage bin, we've seen this already in the presentation. So this is just my my kind of ranges of damage. I went from 1 to 12, if you remember in the presentation. So let's try that again. So 1 to 12, with 1 being no damage and 12 being complete damage, and then a range in between. Vulnerability file, we've seen already as well. So we've got probability distributions of damage per intensity for each vulnerability function. And then we can represent these. So we've got some kind of charting in here as well, just to show for my 3 vulnerability functions, which represent residential, commercial, and industrial. So we're going to run out of time. We've got these kind of distributions, which you can kind of see on this chart is some kind of per intensity. We've got different probabilities of damage at the site. Okay, let's go on, have a quick look. So looking at the exposure data, we've got an example location file, which we can see here. So we already talked about those a little bit. We've got an example account file with not much in there, but nothing in there at all actually in that example. And then we've got the example analysis settings file, which is what I referred to at the end of the presentation, which tells us kind of the number of samples and which types of outputs we want. Here we've got some insured loss outputs as well. And then let's have a look and actually run the MDK. We're done now. Here. So running the MDK, I'm actually going to do my command that I saw before, which was Oasis LMF model run -c with my config file. And I'm going to write that. That's the configuration file that we saw. And this -r flag just tells it where to drop the outputs. If you don't enter that, it's fine. It will just generate a random place with a kind of logical name for the output files. But we can actually just run that. It should take a second. We should see it generating stuff. So it's going through the various steps that we saw. So there's a model preparation step. It's generating our output, our input Oasis files, these kind of abstract files that we use. And then it's running the actual execution itself, generating the losses in the place we told it to generate them, and then telling us that it's all generated. So we should have everything there now. So we should be able to see those. If we just have a look at that, we can see an example here. This is a loss exceedance curve. So one of the outputs we got was a loss exceedance curve. This is just a charting for that. Just very quickly, let's just see if we can get this. See what we've got inside there. Let's have a look. So let's have a look at that. Okay, so this is where it's dropped all of my output files that I've generated into here. What we should be able to have a look is kind of ELT. So let's just have a look at that very quickly. So we can see kind of our outputs in there. So the files are just being generated here. And we could probably, we could try and be even cleverer. One. Okay, so this is our finding our event 3. So these are our event losses for event 3. And we have some types in there. So type 1, just for those who aren't familiar, is a integrated set of statistics for the full distribution, and type 2 is our sample statistics for the 10 samples that we ran. Okay, sorry, I'm probably running over time eating into some of the other demonstrations, but this is all available online. You can just clone this Oasis PyWind repository, fire up the Jupyter Notebook. I think there's quite a lot of information in the README down at the bottom here. Not much information in that README, but the Jupyter Notebooks is available inside there. Right, I'll hand over. Sorry, I see a lot of notes that I'm running, so I can stop sharing now. See if there are any questions. Okay, I see a question saying, thank you for the presentation. Just a quick question. How big are those grid cells, area peril shown on the map? How do you decide on their size? They can be whatever you want. For, I can't remember what they are for PyWind, but PyWind is just an example. For a wind model, they may be kind of typically 1 to 4 kilometer cells. For a flood model, that's obviously much too coarse because you can flood on one side of the road and not the other. So flood models generally kind of 10 meters for floodable areas. They can be variable resolution grids as well. So you might say along the coast, we have very fine resolution, 10-meter grid, 5-meter grid in some cases, some of the flood models have. And then further inland or on hills, they go much coarser. The area peril lookup logic is really, it can be as complex as you want. You just need some kind of point and polygon to map lat longs or some kind of information about the exposure to those. So they can be really whatever you want is the point. I think in wind models, they tend to be 1 kilometer, 4 kilometers, somewhere in that range. For flood models, they tend to be 10 to 90 meters. I've seen some flood models run that. But it's really a per model thing, and they don't need to be uniform. Hopefully that answers the question. Sorry if I run over.
Yeah, okay. I think in the interests of time, so we were going to have a look at the Oasis evaluation, and what that is a repository on GitHub that allows you to bring up a whole system and play about with the API and the user interface, etc. I think in the interests of time, there's pretty complete instructions in the GitHub repository on that. So I think we'll leave showing that for this morning's session. And in the 5 minutes that we've got remaining, I'll just do a very quick walkthrough of the user interface, just to show you how, all of the steps that Ben just showed in the MDK for running the model, you can do exactly the same through the user interface. So I think, Matt, if you're there and want to grab presenter.
Yep, sure. Hi again, everyone. Hopefully you can see this now. I'm just going to log into the UI. And like Mark said, we are running out of time, so I will sort of skip through it fairly quickly. So I do apologize. So this is just quickly the user interface here, just some nodes. We've got no previous analyses. So I'm just going to go ahead and create a simple portfolio. I'll just name it accordingly. If I hit submit, you'll see it up here. And just to say, actually, now there are some more detailed videos on our YouTube channel of these demonstrations of the UI. So if I've gone through it too quickly and you haven't picked anything up, then you can go on there and have a look. So if I just browse to our location file, it's just a small test portfolio, and I'll be running the toy pie win model that Ben has just gone through. So you'll see it's pretty small, it's uploaded pretty quickly. And here would be where you would browse to your account file reinsurance files as well. I'm just going to run something quickly for ground up with no financial terms. So I'm just going to use the location file. We then, next step, once you've created your portfolio and imported, you just go to create an analysis. So create analysis here, and name it accordingly, UI test, shall we say. And just as a note, here is where the user would have their list of available models. So I've just got 2 test models here in my AWS environment. Obviously, whatever you've licensed or used or having available will all be present here. So I just choose the model I want, which is PyWind. If I hit submit, if I just collapse that down, you'll see it bigger. It's just started to generate the inputs. Now, you know what they say, never work with animals, small children, or live demos. So I'm hoping, in the interest of time, that this will take a few seconds. So I've just manually refreshed it there, and you say it's ready. Obviously, the larger the portfolio, the longer it will take. And just quickly, before we actually configure the output and run the model, here is just a validation summary of the exposures. So I've got 15 locations here. But as you can see, 5 have actually failed. So we've got 10 successful and 5 failed here, and I'll explain why. And it's got your model TIV and everything. So if I go to validation map, hopefully you can all see this okay. This is where you've got your 10 successful locations, and I've actually intentionally added 5 exposures to the portfolio that fall outside the scope of the PyWind model, which are these 5, just to show you that they will fail because the model won't cover that area. And for this, just quickly, a new function is a circle or an accumulation function where you can just draw a circle depending on what radius you want. And that will then give you all of the locations within that circle. So then if I then draw a bigger circle, this is 6 kilometer radius, it gives, let's change that again, it will give all 10, 15, if I click on that, sorry, there you go. It will give all 15 locations there, including the ones that have failed because they're all within that circle. And we also have it by country and sub-regional level for each country, but I won't go into those there. So that's just sort of like a basic fundamental mapping function, and it's something we are developing going forward and something that we'll develop further this year. And just inputs. So in the interest of transparency, and this also ties in with what Ben has just been going through as well, you've got some of the input files and the model setting JSON files for the technical user. And this will, if you go to view and content, you'll see your JSON file and all the background information there for models. So they're all available, and you can export them and start reviewing them and things like that if you need to. So all the information's there. Okay, so let's just quickly configure the output before we run the model. So if I go to output configuration, here is where you essentially choose what outputs you want. So if we go to model parameters, we can choose number of samples we want to run, and our loss threshold. I'll keep them at the defaults there. And then the output parameters. So this is quite important. So this is where you can start developing your suite of output reports. So if we look at just the first level, which is the summary, so this is very much the overview, you can choose your financial perspective there, and these will show at the bottom here. So we're just doing ground up for now. And the basic outputs for all risks in the portfolio is just your AAL and your OEP, AEP curves. But if we want to start looking a bit further, we can go to drill down, and here we can start choosing more specifics to look at. So we can start looking at our construction, and again, it will start pulling those same reports for construction, and we can add pretty much as many as we like, or we can group them together, and we could do construction and occupancy, and you can get those 3 basic reports. But there's also one more level of detail we can go into, and that's custom. So we can start really customizing the outputs that we want. Again, financial perspective. So if we just choose all risks, and we want to look at AEP, OEP, AAL, for example. But also we want to look at our construction codes as well. Let's just look at our AAL for those. And you can see everything you've started to build here shows at the bottom here. And you can start adding more and more if you want. But in the interest of time, I'll just execute run. And that essentially is running the model. Because it's such a small portfolio, it should take seconds, fingers crossed. There you go, so run completed. At this point, if you realize there's an output you wanted to select and you haven't, you can essentially go back to rerun and go back and change your selections and execute the model again. But we're happy with ours for now. So if I just proceed to dashboard, and essentially this is, these are the results. So you have your basic summary plots, your AALs, and your loss curves with your information here. And then if we go to plots, we can actually customize our own plots. Again, ground up, let's look at AEP and OEP, name it accordingly. And we've got all risks there. So if you draw your plot, you're going to get them on the same. And again, AAL, if you remember, we did actually run, that's the AAL for all risks, but we did actually run them by construction. So for this case, we have only 3 construction codes that have been used. So we've got the AAL by construction. Obviously, if you, depending on the amount of outputs you've turned on, you get a lot more information here. And also, if you have turned on your location level output, which we didn't, you can also get your losses on a map for each location, but we didn't turn it on, so it won't have any results there. And just finally, your files, so your output files. So these are essentially your CSV files that you can export. So if we just click on one, hit content, you can actually look at your losses by return period. So, you know, your EP curves. And if you hit export, it will just export to a CSV. And all the other information that you selected in your output config will all be available here. So that is it in a nutshell. I apologize, I've rushed through that pretty quickly. Like I said, there's more videos on the YouTube channel, and if I stop sharing, I should be able to see if there's any further questions. I don't think there is, and so maybe I'll hand back to Mark to wrap up. And thanks a lot for your time.
Yep, thanks, Matt, and thanks everyone. Apologies for running a few minutes over. I hope you're all able to stay on. Don't think we've got any more questions, so I'd just like to thank everyone for their time again, and I think that's a wrap up for this morning. Hope to see some of you in person next year in happier times. Thanks very much for your attention.